Welcome back to Applied Algebra. We are finishing up our metric system videos. This is the second video in the group. In the top of the paper here, we have some other units that we may or may not have heard of before. So we have V for volts. We have worked with the ohm symbol before. We have some hertz, farads, henries, coulombs, and we have used the watt one before in the previous video. I also have on here the chart. That is this horizontal chart, which makes it much nicer to move between units. So we'll use that again today. First thing they want us to do is practice the idea of moving from the words to the abbreviations. So 43 kilowatts. Kilo is a small k. Watts is a capital W. So 43 kilowatts is 43 small k capital W. You will do more of those in your WebAssign assignment. Some more of the moving between units in the metric system. This time we're working with volts. Capital M is mega. It's right here in this chart. And we're moving to basic V, which is a basic unit. So when the letter is all by itself, that's a basic unit. We're going to move from a V to a mega V. So basic unit. 1, 2, 3, 4, 5, 6. I've moved 6 to the left. We're going to take the number 1, the decimal being right to the right of it, and we're going to move 6 to the left. 1, 2, 3, 4, 5, 6. We fill empties with zeros. So 1 volt is the same as 1, 2, 3, 4, 5, 1 megavolts. A megavolt is a much larger unit, so it takes much less of it to be the same as a single volt. Next, we're doing 15 gigawatts, sorry, it's gigavolts, to kilovolts. Giga is a capital G, and we're moving to a little k. So 1, 2, 3, 4, 5, 6. This time we're moving 6 to the right. 15 has the decimal to the right. Moving 6 to the right. 2, 3, 4, 5, 6. Filling those with zeros. So 15 gigavolts is 15 million kilovolts. Kilovolts is a smaller unit, so it takes much more of them than it would if it was in a gigavolt. Other things that we sometimes have to work with are temperature. If you've ever talked much with somebody who's from outside of the US, they always think of their temperatures in Celsius, where here in the United States we talk about our temperatures in Fahrenheit. So we have to be able to convert between them. These are the two formulas. So if I'm trying to go to Celsius, I use the first one. If I'm trying to go to Fahrenheit, I use the second one. Example 4 says change 140 degrees Fahrenheit to Celsius. Since I'm going to Celsius, I'm using this first one. So C equals 5/9. Our F is 140, so I'm going to plug that in where the F is. So this is how it is to use a formula. Again, if you have a calculator, this is where you'd want to go ahead and grab it. And I obviously did not have my calculator up already. So 140 minus 32, and then we're going to multiply that by 5/9. If you, again, don't have a fraction calculator, just hit times 5 and then divide by 9. So in Celsius, it is 60 degrees Celsius. We're going to do opposite. On the next one, we're going to go ahead and move to Fahrenheit. Trying to erase that, but for some reason it doesn't want to erase. Since I'm going to Fahrenheit, I'm using the one on the right. F equals 9/5 times our Celsius number, which is -16, and then we're going to add 32. So we really haven't talked about order of operations when you're doing those, you have to make sure that we multiply before we add. So on our calculator, I don't have a fraction key on this one, so I'm just going to go 9 divided by 5. I'm then going to times by negative 16, and then I'm going to add 32 to that answer. And so negative 16 degrees Fahrenheit, which is cold, is 3.2 degrees Fahrenheit. So we definitely know that that's cold because we know anything under 32 is freezing. Okay, so let's see what's next. So the last part of this is not just messing with the metric system, but being able to go back and forth between the metric system and our US conversion system. So I have a bunch of table or a chart here for you. All of this I have placed in a separate one that you can print out. So you don't have to have all of your notes. You can just have it all by itself. And again, I would have that printed out before you take your test on this. Example 6 wants us to convert or change 30 kilograms to pounds. I'm going to go back up and I'm going to look for something that talks about kilograms and pounds. Now kilograms is a metric, pounds is a US, so I definitely have to be able to go between a metric and a US, and I'm looking for kilograms and pounds, which I have just found. Here, 1 pound is 0.454 kilograms. Now what you might notice is there's more than one option. It doesn't matter which option you use, you just need to pick one. So I kind of like the number 2.2 pounds better. It's easier to remember, so I'm going to use that option when I do this problem. 2.2 pounds is 1 kilogram. We're going to go ahead and go back down to our problem. On these, you're going back to the unit analysis, so we're going to be using our table again. I have 30 kilograms, single unit, so I'm not using the bottom. And it said it was 2.2 pounds, was the same as 1 kilogram. Since my kilogram is on the top on the left, I have to make sure it's on the bottom in the next one. Remember that we do that so that our kilograms can cancel out, leaving us in the unit we're trying to go to, which is pounds in this case. We do top times top, 30 times 2.2. We only have the number 1 in the denominator. 30 times 2.2 is 66 over 1, so it's 66 pounds. So our unit analysis is coming back in this last section. Now we're going to change 4 inches to centimeters. Inches is what we use. Centimeters is what they use in the metric system for doing length. So I need something with inches and centimeters. Inches and centimeters. So right here on the top, 1 inch is 2.54 centimeters. Again, you might notice there's more than one option. I don't care which one you use. I'm going to use the 2.54 just because I'm more used to that one. Sorry, I got a little something in my throat. 4 inches, and it was 2.54 centimeters is 1 inch. Since the inches are on the top on the left, I need to put the 1 inch on the bottom so that they cancel. Inches are out of here. I'm in my centimeters, so I'm ready to go ahead and do the multiplication. 4 times 2.54, the bottom is a 1. This one I'm not doing in my head, so I'm going to grab my calculator. 4 times 2.54, 10.16, and my unit is centimeters. So a few more examples, and of course we have to do a few that have more than 1 unit. So we have 3 left. how many square feet are in a rectangle that is 12.6 yards long and 8.6 yards wide. Now this one, I don't know if you've realized, is a US system to a US system. I have yards here and I have feet here, but I have it squared. We haven't really done a squared one yet. If you don't know how to find area of a rectangle, it is length times width. So that's the first thing we're going to have to do, is find the area of this rectangle. So we're going to do 12.6 times 8.6. And my calculator tells me it is 108.36. And because I took a yard times a yard, that's a yard squared. So now I'm going to have to use my unit analysis and set up my chart. So I have 108.36 square yards. And I'm trying to look for something that has square yards and square feet. So I see a bunch of squares, and here is a square yard and a square foot. So 1 square yard is 9 square feet. One square yard is 9 square feet. And sometimes I just write them down real quick so I don't forget them. If you're going to have your table next to you, there's no reason you would have to write it down. Since my square yard is on the top on the left, I have to have my square yard on the top on the bottom, which puts my square feet on top. My square yards cancel, leaving me in where square feet. Ready to multiply. 108.36 times 9, and I have the 1 on the bottom. 108.36 times 9 is 975.24. Since it's over 1, nothing changes, and that is now in square feet. So maybe when you had to, if you're going to fill this in full of something, cover it, and you needed to order it in square feet instead of square yards, this is how you would convert it. The next one is in cubic. So it's very similar, we just have to look on a different part of the chart. We are going to do the US system to the metric system on this one. Looking for square feet to square centimeters. So here's some cubes or powers of 3, square feet to square centimeters. Double check that to make sure that is what we were looking for. Yep. Okay, so 1 square foot is 28,317 square centimeters. 28,317 square centimeters is 1 square foot. So I can go straight to my table. I have 84 cubic feet, which means I have to put the cubic foot in the bottom since it was on the top on the left, and the 28,317 cubic centimeters on the top. My cubic feet cancel. Top times top, so 84 times 28,317 over my 1. 84 times 28317, 2,378,628 cubic centimeters. Lots of a very small unit. Okay, so the last one is one of the ones where we have multiple units. So as you look at this, you'll see we have 415 pounds per cubic foot, and we're switching to grams per cubic centimeter. So we have to switch both the pounds to the grams and the cubic feet to the cubic centimeters. So let's first go find what we know about pounds to grams. looking for pounds and grams, getting rid of these ones we are not using right now. Pounds and grams. So really I'm not excited to have such a long number. Let's go ahead and use, oh, that's kilograms. Oh, here, 1 pound is 454 grams. So let's bring that back down. 1 pound is 454 grams. Okay, now we need to find something with cubic feet and cubic centimeters. Oops, those are squareds. Cubic feet and cubic centimeters here. So that's what we used last time with the 28,317. So that's nice, it's already there. I should have just looked up. So 1 cubic foot is 28,317 cubic centimeters. So now we're ready to go ahead and do our unit analysis. So I have 415 pounds, but I do have a second unit, so down here on the bottom, it's 1 cubic foot. Whenever there's not a number, it's understood to be a 1. So I'll just start with my pounds. Since I have a pound on the top, I have to put the 1 pound in the bottom, which puts the 454 grams on top. So my pounds cancel. Now I'm going to deal with the cubic feet. So since the cubic foot is in the bottom, I have to put the other cubic foot on the top, which puts the cubic centimeters in the bottom. My cubic feet cancel. So the units that are left, I have a gram on the top and a cubic centimeter on the bottom, which is how it reads in the problem. So I know I'm good to go. All the numbers on the top get multiplied. So it's 415 times 454 times 1. The bottom is 1 times 1 times 28,317. In your calculator, 415 times 454 times 1, 188,410. 1 times 1 times the 28,317. Do that in division now. Not a whole number, which is okay, so we're just going to do a little rounding. So it's approximately 6.65 grams per cubic centimeter. And when you do these on WebAssign, they will give you a little bit of leeway. And they actually should tell you what to round to, but if they don't, it should give you leeway. If for some reason you're not finding it's cooperating, let me know and I'll help you with that. Okay, if you have any questions, send me an email and we'll figure it out. Have a good one.